this video, we'll talk about another discrete random variable, the Poisson random variable. Now, when does the Poisson random variable become relevant? It's discrete. So what you want to do is look at a situation in every small length of time, either 0 or 1 events happen. And if the occurrence of events in different time periods are independent, you'll have a Poisson random variable. Okay, and all you need to know to get Poisson probabilities is the mean number of events occurring, or mean number of successes. So, some examples. Arrivals at a Starbucks. Okay, and a small length of time, either 0 or 1 person arrives at a Starbucks. So if you want to know the probability of a certain number of people arriving at a Starbucks in, let's say, 8 or 12 hours, you could use the Poisson. Number of accidents a driver has in a year. Let's say has in 6 months. In a small length of time, either you have 0, hopefully, or 1 accident, and basically the number of accidents you have, let's say today would be independent of the number of accidents you have tomorrow, assuming that you can still drive the car. Okay. Number of misprints in a book. Each page probably has 0 or 1 misprints, and so basically the number of misprints on one page is probably not influencing the number of misprints on another page, so you could use the Poisson random variable to determine probabilities of a certain number of misprints in a book. Okay, so let's do a couple of examples here. The function we need is POISSON.DIST. You give me the number of successes, the average number of successes you expect, and true or false. True means you get the probability of less than or equal to X successes. False means the probability of exactly X successes. So suppose 70 people on average per hour come to a Starbucks. It's open 14 hours. What is the chance at least 1,000 people come? Well, since it's 70 people per hour, the mean in 14 hours is just 14 times 70. So the probability of at least 1,000 is 1 minus the probability of less than or equal to 999. And so the mean was 980, and you want the word true. See, that will be what you're subtracting off is the chance of 0 through 999, which leaves you the chance of 1,000 or more, which is 27%. Okay, let's suppose a teen driver has an average of 0.3 accidents in a year. What is the chance of 0 accidents in a year? Of 0 accidents in 2 years. Okay, well, the mean number of success is an accident, unfortunately, is 2 times 0.3, which is 0.6. So I could do the chance of 0 accidents. The mean is 0.6, and I could do a true or a false, but let's do a false. Okay, that's a chance of 0 accidents, would be 0.5481. Or I could do it true, because less than or equal to 0 is the chance of 0. Works the same. So an average of 1 misprint per 100 pages. Chance a 500-page book has less than or equal to 3 misprints. Okay, so the mean would be 5 times 1, because it's 1 per 100 pages. So the chance of less than or equal to 3 misprints would be 3, and the mean is 5, and we want the word true to get the chance of less than or equal to 3. That's 26%. And the Poisson can be used as approximation to the binomial when the chance of success is small. Let me just illustrate that. Let's suppose 1 of 10,000 people wins the lottery in a given week. Okay. Look at 100,000 people. What is the chance at least 10 of them win? Okay, now if I do this with the binomial, n is 100,000, p is 0.001, success is you win, and the chance of at least 10 is 1 minus BINOM.DIST we want 9 successes, less than or equal, subtract off less than or equal to 9. And we have 100,000 trials. We have 1 chance in 1,000. And we go like this. One minus BINOM.DIST. The chance of it, this should be 10,000, I'm sorry. Okay. So if you have 10,000 people, the chance, okay, that's the chance at least 10 people win. So let's do that with the Poisson. So the mean number of people winning is simply 10,000 times 0.001, and that's 10. So the chance of at least 10 would be 1 minus Poisson.DIST. 9 people winning, 10 comma true. And they're basically the same number. Okay, so that Poisson approximation to binomial may be a little bit quicker when you have a small probability of success and a lot of trials in a binomial situation. So again, the Poisson random variable will be used when in a small length of time either 0 or 1 event happens, and if occurrence of events in different time periods are independent, don't affect each other, Poisson will probably give you good estimates of the probability of a discrete random variable. By the way, the first example of the Poisson random variable was by Simeon, I believe, Poisson. He was analyzing number of deaths by horse kick in the Prussian army in a year, and I would think in a small length of time there would be either 0, hopefully, or at most 1 death by horse kick in the Prussian army. In the next video, we'll start talking about perhaps the most widely used and important random variable, the normal random variable.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.